What we're going to cover in this video tutorial is how to use the GMARC change detection software with fuzzy inference systems to threshold a demographic difference. The advantage of using a fuzzy inference system is it gives you a flexible way of trying to estimate spatially variable error surfaces for your individual DEMs, and then you can propagate those into each other and threshold them in the same way we have in past surveys. So what we need to do in order to undertake this analysis is know where our tutorial data is. We're going to use the same Sulphur Creek tutorial data that we've used in the past. So I'm looking at the 2006 topo here, and we've also got our 2005 topo underneath. And then we're going to use these fuzzy inference systems that are in there that we haven't taken a look at before. And all that's included, we're going to do a simple two-rule system that's based off two inputs, and those inputs will be a slope analysis. So here's a slope analysis from one of our surveys, and point density. And so basically point density is our proxy for sampling, and slope analysis is our proxy for topographic complexity. And the two-rule fuzzy inference system we're going to use argues that that an estimate of the error on a cell-by-cell basis should be a function of those two inputs. So you don't need to have it loaded here in the table of contents, but I just wanted to show you where that was. So our first step, now we know where everything is hiding, is to go ahead and load an existing project. We're going to use the same project that is on our desktop that we've used in previous tutorials, so we need to navigate down through the users to our username to our desktop, where I've hidden this SCDOD project. And I can tell that this is a project because it's got the inputs and simulations subfolders in it. So I click OK, and I will next go to the Configure Simulation tab. And all the controls are grayed out until I give an example name. You can call this whatever I want. I'm going to just call it FIS Video Tutorial. Once I hit Save, it unlocks the controls. Because we're going to be grabbing the files from the input folder and not having to navigate back to the tutorial data folders, I'm just going to hit unclick the Copy DM Project Input folder. First thing we want to do is load up that newer DEM, which is the February DEM. And then, unlike in the previous tutorials, we are going to use this Load Input tab, and we're going to associate some input files with that tab that will be used in the fuzzy inference system. So we've got a point density grid here. Bring it up, and it asks, well, what kind of input is it? So it's point density. Again, we don't need to copy it for this example. And then I'll grab the other one, which is SA for slope analysis. And now both of those input files are associated with the new DEM. If I switch over to the old DEM and bring up the 2005 DEM, and then grab its input files, point density again, and slope analysis. Now I've got those. And so if we switch over to the uncertainty analysis tab, we've gone through how to do some of these. We've even gone through an example with spatially uniform errors, how to convert those to a probability and threshold the demo difference based on probability the change is real. We're going to use this option. We'll threshold it at a 95% confidence interval, but what's going to be different is in our individual error analysis for the surfaces, instead of spatially uniform, we do spatially variable using a fuzzy inference system. We select both those inputs, and then it sees, those are the same inputs as one of my default inference systems. So if I want to use this one that it's suggesting, I have to make sure that I click on the radio button and say, yes, I want to use that. In another tutorial, I'll go through how to edit these, build custom ones, and what's actually in these inference systems. For now, let's just figure out how to push the buttons to get through one of these analyses in this change detection software. So we've done that for the new. Come over, we do the same for the old. We're going to use the two inputs, use the default. Now we can specify some output options. We'll do an edit as imagine image, and we'll add all these outputs to the view. Go ahead and hit validate. Looks like we've clicked all the buttons correctly. We'll hit run and notice that it's building this fuzzy inference system for the new and the old, and then it's thresholding it, and then it's complete. And what it's added to the display here is the following. So we can see that there are two air surfaces that have been added. One is a new, and the other one is an old air surface. Turn off some of this stuff underneath here. And so the important thing to note is that they're different, and that the errors range from the dark values 1.5 centimeters up to about 50 centimeters. And so that is a lot different than if we used a spatial uniform error. This was a total station survey of something on the order of 7 centimeters, let's say. Now we've got quite a bit of spatial variability here. That has been propagated through, and then this is our raw unthresholded dim of difference. Recall that to change the display properties of that, its symbology, we want to use a classified one, and then we can import a symbology that I provided to you in the tutorial data here. It's covered in a previous tutorial, so that looks more like the dim of differences we're used to seeing. And then if we update the symbology to classified for the threshold dim of difference, and then take that symbology so it's the same as that other layer. What we can see here is if we turn off the unthresholded dim of difference, this is our threshold dim of difference based off the propagated errors from the fuzzy inference systems being applied independently to each DEM. And so we get quite a bit of a different distribution. If we want to take another look at that, we go into this FIS example video tutorial, the FIS example simulation we just made. Here we've got the gross distribution that you're used to seeing, but we've also got now the thresholded distribution, and that thresholded distribution is takes quite a different form than our previous thresholded distributions, which just chop the middle out. This takes little bits of information from all over that range of error values that it was calculating. And the output rasters, again, are in the output rasters folder. And so that's all we wanted to cover here. There's another video tutorial that goes through the theory and background on this and how to customize those fuzzy inference systems.